20 and 121 and practicing the simple mole-to-mole problems known as stoichiometry. So stoichiometry takes all the math that we did in the mole unit and apply it to chemical reactions. So a balanced chemical reaction is the science version of a recipe. It shows us how the amounts of reactants that are needed to produce a certain amount of products. The key thing is the reactants to the products, they are represented as moles. So those coefficients in front of each formula to balance it. So the coefficients in our reaction are the relative mole ratio. And that relative mole ratio is empirical in nature because it's the lowest whole number ratio in which the reactants combine to form those products. To help you in this journey of practicing stoichiometry, we have what we call an expanded mole diagram. So if you just look at the left-hand side, it'll look like the mole diagram we did back on page 88, and now we have its mirror image. The key to this is that the left mole diagram here, this is where we start. And we travel to someplace to the right-hand side, so our math will end somewhere on the right. So what we start with, this is a substance in the reaction. We have a measured quantity. So we have a known quantity. We either know its mass, its volume, its particle count, or simply the number of moles. And then we follow this roadmap to determine the moles, mass, volume, or particle count of a second substance in the same reaction. So let's take a look here at an example. So first off, I'm just going to read what we have to come up with. So I see how many. So how many, that's what we've got to come up with, the moles of oxygen. So remember, our math has to end somewhere over here on the right-hand side. So I've got to come up with moles. So this is going to be my end point. I've got to get to this box. So that's where I'm going to end. And it tells me the substance, I have to come up with a number of moles. This belongs to oxygen. Well, to get to moles of oxygen, I have to have some starting information. So when I take a look through, I see, okay, I have a starting quantity. So this is where I'm going to start my math. So my start side is over here, and I have a value in moles. So this is where I'm starting in this problem, and I keep reading, and I notice that this number or this quantity of moles belongs to H2. So I know that I'm starting with the substance H2, and I got to get to something about the substance O2. So I'm going from moles to moles. So right here, this is the pathway. So this is a simple setup. So let's just get our minds wrapped around how we should start showing our work. We're just going to do the bare bones of dimensional analysis. So I know, based on the questions, the number of moles that I have for H2 is the 5 moles. So that's what belongs here. So I have 5.0 moles of H2. Now, mathematically, wherever I cross the line, whatever line I'm crossing, that means I need one of those equivalences to do the math. Well, I know that mathematically I want to make moles of H2 disappear, and I want moles of O2 to appear. And in the end, I want to end up with moles of O2. So I've just got my dimensional analysis set up. In order to do this math, that means I need a relationship here. So this relationship when you cross from moles of one substance to moles of a second substance, this information comes from the balanced reaction. So let's take a look at the reaction that has H2 and O2 present in it. So I'm going to move back up. So I have H2 reacts with O2 to form water. I notice on the left I have two H's. I have two H's on the right, so that's good. But on the left I have two O's and only one O on the right. So I have to make my one oxygen raise up to a count of 2. So I'm going to put a coefficient of 2 in front of H2O. That makes 2 oxygens, so that's good. But it changes my count of H's from 2 to 2 times 2 to 4. So now I have 4 hydrogens on the right. Go back, and I need to put a coefficient in front of the hydrogen on the left. So my H count is now 4. The O2, since it doesn't need any coefficient of 2 or greater, I'm just going to write it in so I can see it. I understand it is 1. So here's the thing. These numbers, those coefficients that we write in before a chemical formula in a balanced reaction, they represent the relative mole value, the lowest whole number ratio of moles. So I need 2 moles of hydrogen gas to react with 1 mole of oxygen gas to form 2 moles of water. So how many moles of each substance are present? That is just looking at their coefficients. So in this recipe, 2 moles of H for every 1 mole of O2 will make 2 moles of H2O. Now, the next thing that I like to do for myself, because I get a little bit distracted here and there, is I like to focus on, out of all the substances in the reaction, I like to focus on which ones I need in the math. So I know that I need H2, so I need to focus on this piece of information and O2. So for my math, this is what I'm focusing on to solve this problem. I'm just ignoring this for the math problem. So now I have my information. So moles of oxygen, look right there, it says 1 mole. So for 1 mole of oxygen in the balanced reaction, there needs to be 2 moles of hydrogen. Mathematically, moles of H2 times moles of O2, the whole thing divided by moles of H2. Since moles of H2 is upstairs and downstairs, I'm allowed to cross it off. It reduces to 1, so it's no longer present. So the unit and labeling I'm left with is moles of oxygen, where I needed to get to. Now it's the math. 5.0 times 1 divided by 2, that's pretty straightforward math. So it's 2.5 moles. Let's look at a couple more examples here. So on page 121,